My name is B. Sadish. My project guide number is J. Chanduraja. My project guide is A.S. Manipandi. My project title is Particle Stress Analysis of Friction Stir Welding. Abstract. The welding process of butt joint and T-joint using finite element analysis is presented. The basic metal is aluminum alloy 6351 and the filler material is alloy 6063. The industrial welding process requires high degree of process security. The correct design of welding procedures is essential for the quality of process. It is needed for programming of welding robot among others, which include moving heat source, material deposit of binary aluminum, temperature dependent material property, metal plasticity and elastic heat transfer and mechanic analysis. On the way, the thermal mechanical coupling is assembled. The friction stir welding means this is solid state joining process. That's why invented in 1991 at the Welding Institute, UK. The welding direction produces the joint. Maximum temperature is 0.7 to 0.9 of the melting temperature and larger temperature gradient is avoided. The aim of this work to perform fatigue assessment of friction stir welding aluminum. Experiment fatigue assessment of friction stir welding profile capability of critical distance method to estimate the fatigue's life for welding location basic metal. The capability of the critical distance method for predict the failure location of the panel. Of Euro Code 9 and IAW recommendation for fatigue assessment of friction stir welding used in the project. The existing material property density 2.6 to 2.8, tensile stress 250 compared to the new material. This is more benefit. The 2D specification welding element is diagram. The structure of butt joint parts, T joint, welded part, the two fixed parts, mesh the barrier mode of connector standard, meshing for butt joint, meshing for T joint, and is used in the AutoCAD statical structure. The two rod is joined by using static structural. One rod is base metal and another is electrode. Coordinate system by using total deformation to check the deformation of this butt joint. Maximum principal stress to check maximum principal elastic stress to check total deformation for T joint to be analyzed. Direction deformation for T joint. This is equivalent elastic strain for T joint. Another one is shear stress. And then main advantage of this static pressure stir welding is the solid state process can be applied to all the major aluminum alloy and avoid problem of hot cracking, porosity, element. The advantage is mainly in big mass production factories. Fatigue stress welding does not apply the specific welding skills instead of manual interventions. No shielding gas or filler wires are required for aluminum alloy. The absence of fusion remove much of the thermal consumption associated with the solidification and cooling, leading to significant reduction in deposition. However, it is not a zero distance technique. Finally, the conclusion is in this study, fatigue performance of linear friction stir welding, catch panel and lap sheet specimen of 6360 aluminum alloy, sheet of 2 mm thickness are experimentally and numerically investigated. All fatigue parameter referred FDP is used to make the accounts okay. Finally, compare the lab shear specification. Thank you.